Hello guys, welcome back to my channel. Sorry, yesterday I couldn't upload a video. I was busy in my some of the office works. So let's continue. So as you have seen till now, what we have done, we have imported the dataset and we have done the some basic sanity checks like checking the null values and creating dummy values kind of things we have done. So let's continue. So in today's video, I will go ahead with data cleaning and then we will start splitting our data and training the model. Okay, so let's go ahead. So first of all, I will delete the remaining dummy keys. Okay, so to save our time, what we have done, I have already uh, written the code. I will just paste it here. So what it will do, it will create uh, the dummy variable wherever required, and it will delete the columns if the extra column which we don't need. Okay, so let me run this code. So as you can see, all the dummy variables has been created. Let me print the head once. If you are not getting what I am doing, you can refer to my previous video. You will get an idea. And if you can see here, the dummy variables has been created for most of the columns which we have mentioned, like multiple lines. Okay, so if you check for multiple lines, the dummy variable has been created. Okay, so in same manner for all of the things we have created a dummy variables. Okay, now let's delete the repeated column. So if you can see contract, we are getting the original column also, and we have created dummy also for this one. So we will create the old column basically. So let's go ahead and delete them. So let me run this. Okay, so all the extra columns got deleted for which there was the dummy variable. Okay, and also the variable which we don't want in our model training. Now if we see telecom dot info, if we see the total charges column is in float. Okay, so okay, total charges column is in float. Run all. Okay, so it's already in float. I think I have created it as a float already. No worries. Let's go ahead and checking for now we will check for any outliers in our data. So what is outlier? So let me open my Excel first. Okay, for outlier is basically, suppose you have a salary column and you have salaries like 12, 10, assume this in lakhs or thousand if you as you want, 15, 20, and one value you get as 200. Okay, so this 200 value is outlier for all of this column range. So if you see, the range of the data lies generally between 12 to 20, or we can say 12 to 12 to 10 20 in the range of, but one value is out of the boundary level. Okay, and it can affect our model training. It can decrease the performance of our model. So to overcome that kind of problem, okay, now what we will do, we will check for the outliers. Okay, so let's go ahead and we will represent our data in percentile to check for any outliers. So first of all, let me create column names which create the values, and which are the columns which we will use to train our model. Okay, Now let me describe them using the describe function. Okay, so what does it means? uh, I will tell you, like we are dividing our data in 25%, 50%, 75%, 95%, 99%, and we are checking like any higher spike in the data or any outliers in the data is present or not. So here you can see it look like a normal distribution of data and there is no outlier as such in the data which were found. Okay, so we are good for now. Another thing what we can do, we can check for the null values. Okay, so what we will do, we will check for the null values, whether there is a null value or not. So if you see, there is no null value here. Okay, see, there is no null value here. Now let's train and split our data in train and test sets. So how we do, we have already command for that. Okay, so let me go ahead and train split our data set. I have done in the previous model training also, you can refer that video also. And what we do for training and splitting our model, so basically splitting our data, we use train test split function of scikit-learn library. Okay, okay, now what we will do, there are two feature variable which we want to put it into a separate variable. Okay, so based on which the prediction will be done, so that is the customer ID and the churn column. So if you remember, the churn column was the value which were storing the value whether the person will churn or not. So that one, and customer ID because we want to identify the person, so that could be done using this customer ID. So both of this we will put into the x variable. And now what we will do, we will put the response variable into the y column. Okay, okay, sorry, what we have done, we have put everything apart from churn and customer ID to this x variable. And we have put churn, the predictive variable, basically to the y variable. Sorry for my mistake. Okay, now let's run this. Okay, now we are good. Yes, now we will split our data into 70-30 ratio, which we have done earlier also. So I will just go ahead and yeah. So here what is happening, we are dividing our data set into two parts, train and test, where 70% of data we will use to train our model, and 30% of data we will use to test our model. So suppose we have 2000 rows, so approx like 1800 rows I will, or 1700 rows I will take to train my model, and remaining 200 or 300 rows I will need to test my model whether my model is working good or not. So for that purpose I have splitted our data. Okay, now let's do some feature scaling. Okay, I will do some feature scaling. So what do we mean by feature scaling? Okay, suppose we have two columns. First column is having value like 12, 20, 20, 15, and the other column value is like, suppose I will say something like bonus. Bonus value is something like 10,000, 15,000, 18,000. Okay, 1,50,000, some values like that. So what will happen when I will train my model? What will happen basically that this column will be have greater weightage that than this column. Why? Because values in bonus column is having large number of data, or large like we can say large data compared to that salary column. So this column will be bonus column will get more weightage due to this. But this should not happen when you train a model. Each column should be treated equally. Okay, so to overcome this situation, we use feature scaling. So what we will do, we will take the mean and the max, and we put some formula like x minus mean divided by x minus mean plus minus x plus max, and we do the feature scaling. So our data will be converted something like 0.33, 0.44. I am just giving an example, so that not be the exact output, but yeah, our data will look like something like this. Okay, and for this one it will come like 5032, something like this. Now both of the column values will be in the same range. Okay, and when we will train our model, the model will give equal weightage to the both of the column. So this is something known as feature scaling. Okay, so how do we do feature scaling? So we will use standard scaler. Okay, so for standard scaler we can use scikit-learn dot pre-processing, and we will import standard scaler. Okay, now we will do the feature scaling of the columns. Total charges. Okay, and I forgot to initialize this one, so first create object of a standard scaler, and then you can call this. Okay, so what is happening here is now we have like done the feature scaling using this standard scaler. Okay, so if now I print the head, just notice the value in the total charges and the monthly charges, and if you can see the tenure, all of the volume are converted into percentile. Basically all the values get converted in such a way that equal weightage will be given to all of these columns. Okay, now from my entire data, I want to see the churn rate. Means how many person are actually uh, transferring or switching to any other company. Okay, so let me put the formula for this, and then I will tell you what the formula is. So basically churn is sum of the total churn. Okay, and the length means the number of the churns, number of the rows in the churns into 100. So if we put this, we are getting something like 26.53. So we can say that 27% of people are getting churn to a different different company. Okay, now we'll do some data visualization to see the correlation of the columns. Okay, and we will delete the highly correlated columns also. So why we delete a highly correlated column? To remove the effect of multicollinearity. Okay, we remove the like highly correlated column. So let's go ahead and visualize the column and their correlation. For visualization I will use two libraries, basically Seaborn and Matplotlib. Okay, and we have used this earlier also. So I will not explain this code so much because we have already done this earlier in my earlier videos. Okay, now if I want to plot the graph, you can see some of the columns is like having very much like correlated to each other. So if we see our churn, okay, if we see the churn variable, which is our predictive variable, and if we see here the graph, some of the columns are like we can say highly correlated to each other, and we don't want that case to us. Okay, so what I will do, if you see, for example, if you see multiple lines no, where is multiple lines no, you can see the highly dependency between all these columns. Online security or device protection no, you can see here. So we will delete those columns which are having like higher higher dependency between like each other, or having higher correlation. Okay, so let me go ahead and delete, and we will redraw the graph. Okay, so first of all, let me delete all those columns and draw the graph again after dropping the highly correlated columns or variable, we can say. Now our graphs look good. So if you see all the highly correlated values 0.82, 0.63, all of these has gone from our graphs, and now our graphs look cleaner. Okay, so now we are good, and we will build our first model. Okay, so for building the first model, I will use stat model. And how do we train the model? So suppose let's call our first model as log m1. Okay, and because it's a logistic regression model 1, so I have given the name as log m1. There is not such like uh, a particular reason why I have given this name. It's just for logistic regression model 1, so I have given log m1. And when I train this model and I print the summary, you can see some of the observation. Okay, so you can see some of the point like what is the p-value, what is the coefficient value, what is the standard error rate. All of these details we can see here, and our model has been trained using this. Okay, so in next video we will see how to train the model using RFE. What is RFE? RFE is basically redundant feature elimination. So what we do in that approach, first we consider all of the columns to train the model, and then we start deleting one by one which are not giving uh, a higher weightage to our model, or which are reducing the result of our model, or reducing the, we can say, quality of our model, so accuracy of our model basically. So we start eliminating those columns, and finally we get to a point where our model is giving highest accuracy rate. Okay, so that's all for this video. Thank you all.